Here on our campus, rapid growth has had detrimental effects on local streams. High percentages of impervious surfaces allow large volumes of stormwater to carry pollutants from densely developed areas directly into streams and water bodies on campus. This can cause an array of problems such as downstream flooding, degrading of aquatic habitats, sediment deposits, and stream bank erosion. This campus resides in two watersheds, the Eagleville Brook and the Fenton River watershed. In 2004, a total maximum daily load analysis was completed for Eagleville Brook in Mansfield.
Eagleville Brook for several years had been listed as an impaired water. It's the DEP's, they're obliged to figure out, okay, what's causing the impairment. In the case of Eagleville Brook, they were not able to find the smoking gun. They couldn't pinpoint what exactly it was. And this was the first one where they said, okay, the source of the impairment is the fact that this is an urban watershed with very small receiving streams. And so we're going to point the finger at the fact that you have a lot of impervious cover, a lot of pavement, a lot of sidewalks, a lot of roofs that just sends a whole lot of water with a mixture of contaminants into small waterways. You'd probably be concerned about flooding. You'd be worried about erosion. A large amount of water can really erode those channels. You might be worried about downstream drinking water. As you probably know, half the campus is in the Fenton River watershed. That watershed goes to the Willimantic drinking water supply about 7 miles downstream.
In response to these issues, the landscape architecture students have developed a plan to reduce the amount of runoff from urban areas that enter the Eagleville Brook and the Fenton River. We achieve this by introducing a campus-wide master plan to reduce stormwater runoff. Our principal theory to achieve this goal is to redistribute impervious cover. Existing density patterns require the majority of runoff to be piped off campus. Our solution proposes reducing density in specific areas, which could then be used to treat stormwater. The reforestation of the oak lawn not only would treat large volumes of stormwater runoff, but would serve as a new axis within this campus that would intersect the existing academic way, improving overall connectivity. The oak lawn would also feature a retention basin that would collect water during storm events before entering Mirror Lake. Along with raising the depth of Mirror Lake by 1 foot, this would increase storage capacity on campus, enhance diversity, and improve water quality. A constructed wetland would allow further treatment of runoff. Along with aesthetic improvement, this serves as an educational tool to help raise awareness of green infrastructure.
Oh, it's very important that awareness is incorporated with these projects. So it's really the university's responsibility to not only employ these techniques to show, but they also have to showcase these techniques.
These same principles would be used in other treatment trains on campus. The collection of these treatment systems would increase infiltration, reduce pollution loads from entering local waterways, and enhance overall health and welfare for campus and downstream stakeholders.